Good morning, and welcome to another day of Friendo Today. I'm your host, Friendo, and today we are going to be doing some toy problems. Hey, hello! Welcome to the stream. We'll be doing similar streams to what we've done on the previous days. We're going to do some toy problems. Although, of course, it is only appropriate that as soon as I start the stream, I sort of have to go to the bathroom. Let's hold on that for a moment, though. Okay, let's do some easy problems to warm up, just of any sort of variety. Remove duplicates from sorted array. This has a lot of downvotes. I hate it when these questions have a lot of downvotes. It kind of spooks me away from them a little bit. Oh, interesting. So you have to, like, concatenate it up. Okay. All right, we need to do this in place. Okay, let's try this out. So, we first want, we want to keep track of what numbers we've seen. So, const seen numbers equals, we're gonna need a hash here in some way, shape, or form, right? And then we're also going to have to keep track of these indices where we put the values in. Last index equals 0. So what we want to do is iterate across it, check each number. If the number is unique, we know it will get to stay there. Technically, you don't have to use the hash, but I'm going to use the hash because I'm a little more familiar with it, and it handles numbers in an arbitrary order. Whereas in this version, you don't need to use a hash. You can use something even simpler. Oh, modify the input array in place with O of 1 extra memory. A hash breaks that constraint, though, so we can't do that. That breaks the O of 1 extra memory constraint. Well, actually, technically, no. It doesn't break the OV. Because you can make this as big as it wants, but the hash is only ever going to go up to 9. Let's not declare a new data structure, though. Let last index, let last seen number equal null. Okay, and we got to iterate across it. For let I equals 0. I is less than nums.length, I++. Okay. All right. So for each number, we need to check to see if nums if the first number, the number equals last seen number, handle duplicate, else if we see a duplicate, we want to move it up. Ooh, hey, what up, Cubed? I really hate Twitch Mobile. Okay, now I have a picture. Can it start playing? That is the question. I hope it will start playing, Cube Sword. It did not, so I'm in audio only mode. Oh, that's a bummer. Well, how's your day going otherwise, Cube? This doesn't seem right. This seems quite wrong. Good, just taking my break. Only have 3 kids today. Nice. I'm doing all right today. I woke up a little late. I slept through my alarm, which was a little discombobulating, but not by too much, which was good. And now just doing some toy problems. Getting ready for software engineering job hunt. but let's just run it. Also got a call from Moog Inc. like an hour ago. What is Moog Inc.? An aerospace and defense company. Interesting. All right, so let's start walking through this logic and we'll probably rapidly find the errors. Okay. Last scene number, last name is 0. 4. Last scene number is set to num's I. Last index. So the last scene number is set to 1, and the last index is set to 1. Then we come through here. We see that the number is equal to the last scene number. Number's last index. Oh, we need to delete it. I'm not really used to deleting elements from arrays in JavaScript. Well, we don't need to, we don't need to delete it. We can just overwrite it later. That's fine. If num's I equals the last scene number, which is true, num's I is 1, and the last scene number will be 1, then the numbers of the last index of 1, that doesn't do anything. Okay. Ooh, their HQ and main facility is 20 minutes. That's not bad at all. Nice. That could be a cool offer. Hell yeah. Okay. We've found a duplicate. What do we do with it? We don't do anything with it, actually. if the number at I does not equal the last seen number, then the number at the last index is updated to this number. Last seen number equals num/I. Alright, I gotta run to the restroom real quick. Sorry, everybody. That kind of came up pretty quick. Coffee. Okie dokie. Hello. Okay, so there are two events that we need to take account of. Seeing the same number and seeing a new number. If we see the same number, we keep going. Alright, we see 0, we keep 0. We see 0, we know that this is where we need to do the insert. Let insert index equals 0. Maybe it should be null. Okay, so we've seen it. Okay. Okay, so if we see a new number, this one's fucking with me a little bit. If the number at j does not equal the number at I, then the number at I goes up. Struggling on this one a little bit. If the number at j does not equal the number at I, value of I after the increment. All right, cool. The value of I++ is the value of I before the increment. The value of I++ is the value of I after the increment. Ah, okay. So that's just a little shortcut they're doing there to increment it. This one's messing with me. Maximum subarray. Given an integer array's nums, find the contiguous subarray containing at least one number, which is the largest sum, and return its sum. All right. If you figured out the O of n solution, try coding another solution using the divide and conquer approach, which is more subtle. Interesting. Do the reduce. All right. We're going to want to slice out arrays. And then sum them. If you figured out the O of n solution, I have an O of n squared solution. There's an O of n solution where you can go over the array once. Interesting. Well, how would I brute force this? I'd look at every possible subarray. Damn, I am really struggling with toy problems today. Struggling to kind of get into the mindset on them. Var I equals 0, I is less than a dot length, I plus plus. Previous. The previous is the math.max of the previous plus AI or AI. I don't really fully understand how this works. Wait, yeah, it's not even returning a oh yeah, you don't have to return a subarray. You have to just return the max. I need to understand this problem. Okay, so all right, so -2, okay, so math.max of 0 plus -2, -2, -2 is -2. Max is now our -2. Then we look at 1. Previous equals math.max of previous, which is -2. Aha! I get it. I get it. Wow, yeah. Damn, that's slippery. Okay, this is comparing the current number to the running sum of all previous numbers. And if the current number is bigger than the running sum of all previous numbers, then you replace the running sum of all previous numbers with the current number. And then we check to see if the current run of previous numbers is greater than the max. Okay, that makes sense. Contiguous. Okay, now let's try typing it out ourselves. Let the previous number equal 0. Let max equal math dot number dot min value. Okay, so we set it to negative. Then we iterate for let I equal 0. I is less than nums.length I plus plus. We need to take the previous string and set it to the maximum of the previous string or previous plus nums of I. And we set the max to the math.max of previous or max. We return the max. Not quite correct. Previous is equal to Wait, how did previous become 5? Oh, whoops. Man, I'm not having great luck this morning. That's what I fucked up. It's the maximum of the current number, or the previous and the current number summed together. All right, let's take a quick break from some toy problems and let's look at something else. All toy problems in a row like drains my brain really quickly. Introducing new feature, study plan.
Welcome to Geeks for Geeks. I'm Ishan Sharma, and in today's video we'll
Let's check this video out.
be taking a look at how you can get started with freelancing. Let's get started with this video.
I'm curious about freelancing. Well, this is loud.
So if you recently learned maybe web development or Android development and now you want to start earning in college and you just want to have some experience from your skills that you've learned recently.
Earning in college. We'll go with that one.
What can you actually do? You can either get yourself an internship or you can get yourself like a freelancing gig or client. Okay. Now let's talk about freelancing over here because I've already covered internships in a previous video. Take a look at that if you're interested. But today I want to talk about freelancing. Before you get started with it, ask yourself this question. How do you want to represent yourself? What will you actually be? Will you be like a front-end developer, a back-end developer, full stack, Android development, whatever that is, just think about that for a moment. Then what you want to do is that you want to have your own portfolio. This is really important. If you're going for like an internship or you're going for like a freelance gig, you need to have your own portfolio that you can show to someone. Okay, these are the projects that I've done. This is the experience that I have. Certificates won't help you, so don't show off your certificates to any recruiter or to anyone who is trying to find someone who can do their work. So that's really important. The next step would be to ask yourself, how do you want to get your first client? Okay, now there are basically two ways that you can do that. Either you can actually start networking with people, you can start cold emailing people, or you can start using LinkedIn, which I'll talk about in some time. Or what you can do is that you can use a lot of these freelancing platforms. Now you can just go to these platforms. There are plenty of them. You have Fiverr, Upwork, Freelancer, People Per Hour. And basically you can just go, you can create your own profile and you can start bidding on the projects that someone else has put up over there, and then they get to choose whichever one should they prefer. Okay, so that is one way that you can get started. Now the thing is that these platforms are overcrowded. There's just too much
Yeah.
competition,
Yeah.
right? There are a lot of people on these platforms and there are not enough people who want to give their projects, right? So what you need to do is that it will take you a lot of time to get started, but once you are at that level, maybe you've done like 100 projects or something, then you can start charging a lot more. But starting off, it would be really difficult. You need to cost cut. Basically, you need to make sure that you are charging way lesser than what other people are charging, and that is how you will be chosen, right? You will basically need to make sure that you are filling in all the buyer requests when we're talking about Fiverr, but essentially you will have to work a lot harder to get your first client, right? That's what I think. I don't think it's like the best way for you to get started, but of course, if that is the only way you want to go, then that is completely fine. It might take you a lot of time though. It depends a lot on luck also. So yeah, just make sure that you know about this. The
Freelancing
next
sounds
method,
pretty
which I
stressful.
believe in a lot more, is networking. You can just talk to a lot of people. You can create content on LinkedIn so that people will say, okay, this person seems to be equipped with this knowledge and the skill, and we would actually want to work with them, right? So you can do some things like that. You can also start messaging these people who are running some businesses. You can also start emailing these people, and that way you can get your first client. Now, one question that many people ask is, how do we know how much should we actually charge, right? How much should you charge? Or in the beginning, should you even be charging people any money? I would say that you should try to get the first client, no matter if you are getting paid or if you're not getting paid, because that first client is crucial to your success as a freelancer. Just get that first, second, third, just a few initial clients. It doesn't matter if they pay you or if they do not. If they do pay you, that's amazing. But just make sure that you have those first few testimonials. These will be the first promoters of your work and your skill. They'll leave some reviews on your profile or just give it to you in like a letter, and they can just say that, okay, I worked with this freelancer, the work was amazing, he was or she was very quick with delivering whatever work I wanted them to do. And that will be amazing for you, because then you can start showing other people that, okay, this is what my work has been, this is what other people have to say about my work, and so
it sounds like for those first few gigs, you really
be charging this much.
really
you can
gotta
charge
hustle.
on a per hour basis. You can also charge in like a value basis. Now you need to decide for yourself how much value would your project bring to that particular business. So then you can start charging based on the value, or you can just say that, okay, I have like a $10 per hour maybe rate, and so let's say a project will take 10 hours for me, so that cost would be $100 for that particular project. So yeah, it depends on you. At the end of the day, it's really important that you retain those customers as well. Let's say someone gives you some work to create a website. They might need you afterwards to make some edits to the website or do all of these things. So that is why it's really important that you maintain relations with these first few clients. One more thing to remember is that whenever you're using like a website, Fiverr, Upwork, whatever, you want to make sure that your gigs or whatever you put up over there is optimized properly. There is something called as SEO optimization for these freelancing websites. You want to make sure that you are mentioning some keywords. Let's say you have some sort of a gig which says this: I will create a simple e-commerce website for you. Okay. Now you need to make sure that you are specifying a few things that they might be looking out for. Cart can be an example, e-commerce, payment gateway can be an example. So all of these things you want to make sure that you have them, and in that description of that particular gig, and then you make sure that you have some pictures as well that are appealing to the person that is looking at it. So that's just really important for you to keep in mind whenever you're getting started. And yeah, that's just basically what I wanted to cover in this video. If you have any questions, let me know in the comment section down below. That's just really important for you to keep in mind whenever you're getting.
Did I close that video when I walked away? I guess not. Okay. Oh, I hit back. Oh yeah, we already did that. All right. All right, let's go back to leak code. actually, let's do some studying on LeetCode. Specifically, let's go back to graph explanations. Disjoint sets.
Hello, and welcome to this LeetCode video tutorial. In the previous video, we discussed that to implement disjoint sets, we will use the root array to store the parent node or vertex. For the find function, every time we try to find the root node of a vertex, it needs to find the parent node and the parents of its parent node until we find the root node. For example, given this array, how would we find the root node of 4? We have to find the vertex 4 and check whether it's equal to its parent. When they're not equal, this means that 4 is not the root of itself, so we have to search along its parent nodes. Here we find 1. Its parent node is 0, which does not equal 1. When they are not equal, we have to look at the parent of 1, so we find its next parent and check if its parent node is equal to the node itself. When we find that they are equal, we can finally say that node 0 is the root of 4, and it's also the root node of 1. Visually, we will find 4 on the graph and find its parent node, then go to the parent of its parent node until we find the root node. So the root node of 4 is 0. For 1, its root is also 0. So these are the operations we perform in the find function. But doesn't this seem tedious? For 4, we have to find 1, then 0. Then if there's another node 7 under 4, to find the root of 7, we have to check 7, then 4, then 1, and then finally the root node 0. We have to search step by step for the parents. What if we store the root node itself instead of storing the parent node as an element in the array? This means for our find function, we can directly get its root node. Wouldn't this save us a lot of work? To elaborate, let's say we already know that the root of 0 is 0, the root of 1 is 0, and the root of 2 is also 0. For 3, its parent node on this graph is 1, but its root node is 0. So we will change what we store at index 3 from the parent node to the actual root node. Similarly for 4, its parent node is 1, but we don't store the parent node, we'll store its root node. And for 5 and 6, we'll do the same thing and directly store their root nodes. Now, if we want to call find on 6, or find the root of 6, we can just go to index 6 and look at this value. Now we can instantly get the root node, which obviously makes our find function much more efficient. But the trade-off to storing all the root nodes in the array is that every time we do the union operation, we have to perform an extra step. Let's say if 0 and 2 are not connected, now for 5 and 6, their root nodes are 2, and for 2, its root node is itself. This is the case if node 0 and node 2 are not connected. Now if we try to connect 0 and 2, the first thing we need to do is find the root node of 2. Of course, it is 2 itself. After finding the root node of 2, let's choose 0 as our parent node. We'll change the root of node 2 to 0, and now the root nodes of 5 and 6 have changed. It used to be 2, but since the root of 2 has been changed to 0, the root node of 5 and 6 is also 0, so we need an additional step in the union function. That is, when nodes 0 and 2 are connected, and the root node of node 2 is set to 0, we will have to go through all the elements here to find the nodes with 2 as the root, and change the root nodes to the new root node 0. So it's an extra step here in the union function. We have to traverse the entire array, then find the element that corresponds to the root node we're merging with, and finally change the root node to our new root node. This is the extra step. After looking at this idea, let's take a look at the code for QuickFind. We are using a pseudocode here and not any specific programming language. It's human readable, but it will not compile. You can take this pseudocode and rewrite it in any language. The reason we are doing this is that we want to help people using different languages. So here we will have the union find class, which is the same thing as a disjoint set. Of course, because it's a data structure, we will define it as a class. Initially, we need a root array, which is what we have here. Then we're going to have a constructor, so we're going to have a size parameter in this constructor. Size represents the number of elements in the array, that is, the number of vertices. We'll initialize root to have the size of the number of vertices, so root will initially be filled with zeros. Then we will initialize it. Since we have each vertex isolated by itself in the root array, initially the root of each vertex will be itself. Thus, here we initialize the root array by setting all the elements to their indices. Again, the root node of each vertex is itself. Then we're going to have a find function, which basically takes in x and returns the corresponding value at index x in the root array. Since every element will be pointing to its own root node, we just return this value and then move on to our union function. First, we need to find the root nodes for x and y. When their roots are equal, we know they're already connected, so we don't have to perform the union operation. But if the root nodes are not equal, we now have to go through the entire root array once we see a value equal to the root of y. In other words, when the corresponding root node is equal to the node we are merging, in this case root y, then we have to change.
I want to see this part again.
In other words, when the corresponding root node is equal to the node we are merging.
When root I equals root y.
Merging, in this case root y, then we have to change this root node to our new root, which is root x. This way we can make sure that each element in the root array will be the root node of that index. Finally, here is a function that determines whether x and y are connected. Of course, this is also very simple. All you have to do is check whether the roots of x and y are equal. If they are the same, they're connected. If the root nodes are not the same, then they're not connected. For find x, its time complexity is O of 1, because we look up the array directly and then find the value through the index, which is O of 1. For the union function, since it has a for loop here, to go through the whole array, its time complexity is O of n, and will be O of n every time, because you're going through this array every time. For the function to check for connectivity, its time complexity is also O of 1, because it relies on the find function, and the find function is O of 1, so the time complexity is O of 1. Now we have explained the fundamentals of quick find-based disjoint sets. Thanks for watching.
Okay. Quick union.
Hello, and welcome to this LeetCode video tutorial. In the previous video, we introduced quick find-based disjoint sets. Overall, in such a disjoint set, the find operation is very fast, but it leaves more work to the union operation, causing the union operation to be quite slow. In this section, I'm going to talk about quick union-based disjoint sets, which means that the union operation will be faster, but the find operation will take more work. Let's see how we can make the union operation faster. Given these vertices, we want to perform these connect operations. Let's see how we can achieve that using quick union. First, we need a root array. In this array, the indices represent the vertices, while each element will be the parent node of the vertex. In quick find, it will be the root node. However, in quick union, the element of array will be the parent node. Let's see how we can connect 0 and 1. To connect 0 with 1, the first thing we do is define the root node of 0 and the root node of 1. In the picture, we can see that the root node of 0 is 0, and the root node of 1 is 1. So we know that the root node of vertex 0 is 0, and the root node of vertex 1 is 1. We will choose one of them as the parent node. Let's choose 0. Then we connect 1 to the root node of 0. Here, of course, the root node of 0 is 0 itself, so we will connect 0 and 1 and assign 0 as the parent node of 1. Now let's see how to connect 1 and 2. An intuitive method is to connect 1 and 2 like this, and then assign 1 as the parent node of 2. This is the method we introduced earlier. Now I'm going to introduce a faster method, which involves finding the root node of 1. In this case, it's 0. Then we will directly connect 2 to the root node, which means the root node of 2 is neither 2 nor 1. Rather, it should be 0 because we directly connected 2 to the root node of 1. To connect nodes 1 and 3, we will perform the same operation. The parent node of 3 will be assigned as 0. Now we need to connect 4 and 5. To connect 4 and 5, the root node of 4 is 4, and the root node of 5 is 5. So we need to choose a parent node from them. Let's choose 4, and update the parent node of 5 to 4. Next, let's connect 4 and 6. We will again choose 4 as the root node for 6. At this point, it seems like the elements in the root array are all the root nodes, right? So how is it different from QuickFind? I'll give an example here to show the difference. Let's say I want to connect 1 and 5. To do this, I have to find the root node of 1 and 5. Then I will choose node 0 as the parent node. In other words, the root node of node 1 is 0. Now we have to change the parent node of 4 to 0, which is the root of 1. To do this, we will change the 4 in the root array to 0. The new structure will be like this. Now, for elements 5 and 6 in the array, their parents are both 4. But 4 is not the final root. This is different compared to QuickFind. With QuickFind, the root node is stored directly in the array. However, for Quick Union, we must traverse the parent nodes until we find a node such that its parent node equals itself. Then we have truly found the root. After talking about the idea behind Quick Union, let's look at the code for it. Here, the root array, as well as the initialization, is the same as QuickFind, so I will skip it. I will focus on the differences in the find and union methods, as they are the major differences between Quick Union and QuickFind implementation. For the find method, we first have this while loop. What is it doing? It's checking if the root vertex is equal to the current element. If they are not equal, we will continue searching through its parents until we find the current index, or when the vertex is equal to its parent. This means we have found the root node, so we can return it. This allows us to use the find method to get the root node of x and move on to the union method. When I go to union x and y, I have to find the root nodes for x and y and check whether they are equal, because if they are, they're already connected. If they are not equal, we want to set the root of y, which is the parent node of the root of y, to the root of x, so that when you try to find the root of x and y next time, their roots will be equal. This means we have connected them together. Here, our find method can have a worst case complexity of O of n. In our union method, it doesn't have the for loop like our QuickFind method. This means that it will not be O of n every time, but it will still be O of n in the worst case. Why? Because we are using our find method here, which has the worst case time complexity of O of n. So for the union method, its worst case time complexity is also O of n. So here, for union operation, its time complexity is actually less than or equal to O of n. The operation to check whether to connect the two nodes will be O of n worst case as well, because it calls the find method. And that's all for the implementation of quick union based disjoint sets. Thanks for watching. Hello and welcome to another LeetCode video tutorial. In this video, I'll explain why quick union is more efficient than quick find. Here, the code on the left is quick find, and the code on the right is quick union. There are two major differences between the code snippets. One is the find function, and the other is the union function. This is the find function, and this is the union function. The rest of it is the same. For quick find, the find function on the left has a time complexity of O of 1 because it stores the root nodes for each corresponding vertex in the root array. So for the find function, its time complexity is O of 1. For the union function, its time complexity is O of n because each time we find the root nodes of x and y. Here we have a for loop. We have to iterate the root array from left to right, so we get a time complexity of O of n. So for the union function, it has a time complexity of O of n because it has to go through the entire root array. Now let's look at quick union. For quick union, we observe that the worst case for the find method is O of n.
Whew, I'm struggling
So what
here. Okay. Struggling to focus.
is the worst case? The worst case scenario is when the tree is constructed like this, in a line. So to find the root of 4, we have to search node 3, then 2, and finally 1. So in this case, it's O of n. So this will be our worst case scenario. The union function's runtime will depend on the find function. Because the time complexity of this step is not significant, we already know that the find function has the worst case O of n, but this is based on the worst case scenario. So the overall complexity is less than or equal to O of n. For the quick find function, if we want to connect n elements, what will be the complexity? Since each union operation calls the find method, each union will take O of n time, so its overall time complexity must be O of n squared. But for quick union, to connect n elements, the worst case runtime for each union is O of n. So overall, the time complexity is less than O of n squared. So this is why quick union is more efficient than quick find, because only in the worst case is it O of n squared in time complexity. Of course, between quick union and quick find, we're just choosing the lesser of two evils. Neither are very efficient. We'll follow up on this later and optimize our union find even more. Thanks for watching.
Union by rank. Wow, all right. Okay. Easy collection. Top interview questions. This looks good. I like this. Ugh, okay. The more you are able to solve a problem yourself without any reference to answers, the more you will improve. Oh shit, this one was one that was giving me so much trouble. All right, let's keep trying on this one for a little bit. Last seen number, let insert index equal null. If this problem, the key point is to focus on the input array being sorted as far as equivalents are concerned. What is their positioning in the array when given the array is sorted? Two-pointer approach. If nums of I, if the current number does not equal the last seen number, then first of all we need to update the last seen number to the current number. Then we need to take nums at the insert index equals nums at I. Then insert index needs to iterate up. Else if you are not the last seen number, do 112. 112. 112 comes in here. If nums at I, so that'll be 1. If 1 does not equal null, then the last seen number is set to 1. Then the insert index is 0. Put it in at 0. Return insert index plus plus. Holy shit, it worked. Holy shit! It got accepted! Holy shit! It worked! There we go. Yes. Yes! Yes, Queen! Yeah, there's no else. Hell yeah. Hell yeah. Yes, a problem that had been giving me some trouble I figured out. Best time to buy and sell stock too. You're going to array prices where prices I is the price of a stock on the ith day. Find the maximum profit you can achieve. You may compute as many transactions as you like, i.e. buy one and sell one share of the stock multiple times. You cannot engage in multiple transactions simultaneously, i.e. you must sell the stock before you buy again. Prices 715364, output 7. Buy on day 2, price equals 1. Sell on day 3, price equals 5. Profit is 4. Then buy again on day 4, price equals 3. And sell again on day 5, price equals 6. Profit. Okay. Somebody told me back in March 2020 that it'd be good to invest in Pfizer. What's Pfizer stock been doing? Oh yeah, they're doing well. Yeah, look at that. Damn. Yeah, Pfizer stock is on a tear. I had a bunch of Pfizer stock, but I sold it back when I bought my house. Back around this time. Yes, I would say that having the best coronavirus vaccine on Earth is a good... It's good. Your stock price should probably go up in response to that. Okay, we're gonna need nested loops. We're gonna need nested loops that jump ahead. This seems complicated. All right, let's try. Let profit equal 0. let total profit equal 0. Want to do this minus this it's actually this minus this, this minus this, this minus this, this minus this, this minus this. This one because how do you no, we're gonna stick with this one for a little bit even though it's giving me some trouble. Losing my momentum a little bit. We're at about an hour and a half. I think I'll call it there. I'm kind of slipping. I'm slipping. Alright everyone, it has been a morning stream. I will actually probably be back later today for a little bit more work, but I'm going to call it for right now.